Treat? No?
Going to the parade.
Huh?
The parade.
Yeah, you're going to it. Good, yeah. Should be good.
Wow. Yeah.
Is it crowded?
Huh?
Very, very crowded.
It's not that bad. It's not that bad. It's not like St. Patrick's Day, you know. Do you know Halloween started in Ireland?
Is it?
Yeah.
Colin.
I told you this, yeah. It goes back thousands of years. It's an old Irish tradition. You didn't know this? No. Come on. Huh?
How long is it?
How what?
How long is it?
What do you mean?
Halloween?
It's just like one evening. It's like one celebration. What am I doing?
That's what they do with candy picking.
Tonight?
No, not tonight. I think.
When is favorite?
It's the last day of October always.
Favorite.
31st. Why isn't my TV working?
2,000 years ago. Halloween originated in Ireland.
Yes. Yes. There we go. Finally. The ancient Irish celebration. You know. I don't know what it's like. It's like, you know, the way in South America they have what's it called? That celebration of the dead. What's it called? You know the one I'm talking about in South America.
Cinco de Mayo.
That's the one. Yeah. It's kind of like an Irish version of that, just colder and darker.
Yeah, but Halloween's more.
Religion is chapel. You would have forgot.
That's definitely. In China they have
They do in China, don't they? Don't they have something like this?
celebrate for the dead.
Yeah. Do they? No.
You have to.
No, you're not sure?
No, it's not celebrate for life.
What is it then?
It's
Celebrate for your ancestor. Right.
Yeah, okay. A little different. Yeah. Okay, so new chapter. We're starting materials now. Kim, how much is the coffee in Subway?
2.5.
Okay, I was hoping you would say it's less than this. Right, density. And this lesson's not so difficult because it's the start of a new chapter. So we began with mechanics. Now, the reason mechanics is so big is because it's like the basis of physics. You know, so much of physics is about mechanics, and it's the oldest part of physics, modern physics, starting with Newton. Okay, so the order of the course is kind of chronological. What I mean is we start with Newton, which is mechanics, and then in semester 2 we finish with atoms. You know, like Einstein. So it's almost like we're going through time in our understanding, okay? So we're moving on to materials. So materials became really important, you know, like 1800s, 1900s, when people really wanted to study construction and, like plastics and, what are the properties of materials? Because before that people didn't care. They just used wood or stone or whatever, So density is what we'll start with, and we actually talked about density in the first lesson. So you probably remember the formula for density. Do you remember what is the formula for density? Yeah, it's mass over volume. So it's mass per volume, and the formula is mass over volume. And what's the units? The units for density.
Kilograms, kg.
Kilograms per.
Meter.
Yeah. It's mass per length cubed with units of kilograms per meter cubed. Okay. So I know that you wrote this down, but could you write it down again so it's in your materials notes? Is that the first time you saw Joan angry, or have you made her angry before?
She wasn't
She was
angry.
angry.
She wasn't angry, okay. Annoyed?
She was just sounding a bit disappointed. That's it.
Okay, alright.
Starting to get worried.
She was so sad.
Sad, okay, yeah.
And then she said, "You know who you are. That's what makes it."
That's a classic line, alright, yeah.
She didn't specifically say who.
Yeah, she just said, "You
So
know
I'm
who you
No.
are."
So I'm kind of like,
Leaves you wondering.
yeah, is that?
Sorry. What is the L mean?
Yeah, what's L mean here? Length. Length, yeah. So volume is length cubed. Length by length by length. You know, this volume. Okay, so what exactly does this tell us? So what does the density tell us of a material? Like, you know the density of material. So what do you know about the material? I think, Siva, you told us it last time, like what exactly you know when you know the density. How would you explain it? You sure? You told me, like you explained what density is last time, do you remember? Yeah, so what did you say last time? You couldn't have forgotten, you told me it. Are you sure you don't remember? Think back 5 weeks. What is density?
The amount of mass in
Yeah.
the
Yeah, yeah.
volume.
Yeah, that's it. It's like how much stuff you have in the volume. So, some materials have high density and some materials have low density. So, gold has high density. You get a lot of material in your volume of gold, for example. Does anyone know the density of gold? How big it is? No? It's 19,320 kilograms per meter cubed. So if you have a meter cubed, which is obviously a lot, then you would have 19,320 kilograms of gold. So that's gold, obviously. It's a very dense material. What I want you to do is a small revision exercise. I've given you the density of gold in kilograms per meter cubed. Okay? I want you to convert that into grams per centimeter cubed. Okay, so I want you to take, let me just write this down here, 19320 kilograms per meter cubed, and I want you to convert that to grams per centimeter cubed. I'll give you a minute to do this. A little bit of revision. Get an answer, Chow?
No, yes.
Huh?
192 times 10 to the power 6.
No.
Yeah. That's what I got too.
Lads, that's way off. No. Got an answer, Siva? Yeah.
19132.
Yes. That's it. Right, now look, we're having some difficulties here. Let me remind you how to do this. So, kilo is obviously 1,000. Okay, so that's 0.000 grams per meter cubed. Okay, we don't want grams per meter cubed, we want grams per centimeter cubed. So this is 1932000 grams per meter cubed. But what do I want here? Centimeter cubed. So if I put a c cubed here, what price do I pay? I must put a c cubed up here. So how big is a c? A centi. How big is it? It's 0.01. That's a centi. Cubed. Grams per meter cubed. So that would end up being 19.32 grams per centimeter cubed. It makes teachers sad and worried when you have trouble with this. Right, continue. Steva, you got that, or do you need a minute? Are you sure? Okay. So, some materials have a low density. Does anyone know an example of a material with a very low density?
Paper.
Paper's low, but we could go lower. Good, yeah, that's very low density. Even lower. Think about your periodic table. Is there any atom you can think of that has a low density when it's in a gas form? Hydrogen has a low density, and something else? Oh come on! I thought helium. That's used in the balloon. Its density is quite small. Look how small it is, 0.179. Compare that to gold. What was gold? 19,000, isn't it? It's not even... If you have 1 meter cubed of helium, you only have 179 grams. Okay? Compare that to gold. If you have a meter cubed of gold, you have 19,000 kilograms. Huge differences there. And that is helium in the balloons. Yeah. Okay. What would we consider a medium density? What would you consider medium density? No, that's kind of small.
Water.
Yeah, water is kind of considered a medium density. It's. Does anyone know its value? The density of water. Does anyone know it? You used to know it. Does anyone remember it from school? 1,000 kilograms per meter cubed. Yeah? In case you didn't know, that's water. The reason we care so much about it is because actually the density of water is very important in science. Obviously water is very important. I think you understand that. Even though you're not studying biology, you can understand that water is important. But it's important in science as well because of its many properties and usefulness. I mean, it's important in chemistry, like water. What do you call it in water? Like it's a perfect solvent, isn't it? Yeah, that's it. Yeah. It has so many. It's so important because of all its so many useful properties. So it's important to know the density. Okay. Also, you might know this. If something floats in water, it's because its density is less than 1,000, and if it sinks in water, it's because its density is more than 1,000. So it's important to know what the water is. So the density of water is so important. Often we can state density in terms of that of water. So for example, remember we said gold is 19,000 kilograms. Well, we could actually say it's 19 times more dense than water. You can compare it to water. So this gives us our next idea. something we call relative density. It's the density compared to water. So the relative density S is the density with respect to water. So in other words, it's the density of the object divided by the density of water. So if you have something which is a density of 2,000 kilograms, that's twice as dense as water, right? So you say S equals 2. If you had something which is 500 kilograms per meter cubed, what would the S be? It was 500 kilograms per meter cubed. What would the S be? 0.5. Does the S have any units? Have a look, what do you think? Any units? No. Oh, didn't I see you guys at the mosque yesterday?
Yeah.
Yeah. Myself, Joan and Isabel went and we got 3 cappuccinos and 3 coffee cakes. That was our purpose, if you're wondering. There's delicious cake and coffee there at the mosque. Delicious. And I see that you get a student discount as well. It's nice. So, does he charge you less for coffee?
I haven't got a coffee.
Or cake? You haven't gone? You're missing out, man. You're missing out. Have you tried the coffee and cake?
Yeah.
Okay. And do you get a discount?
I think I did it.
How much did they charge you?
Because I ate it with a burger as well.
Oh, okay. That's
But yeah, I got like 5 for both of them.
what?
Yeah.
That's outrageous. Okay, that's good. Right. Now, one use is buoyancy. Does anyone know this word, buoyancy? Anyone know it? Yeah. Floating. So, if S is less than 1, and you put it in water, what would happen? Yeah, it floats. If S is more than 1, like gold, you put it in water, sinks. What about if S equals 1? Well, it neither floats or sinks. It kind of just moves around with the water, you know. Okay. You'll need this table for your questions. It's a table of densities. Now, in the exam, they give you the information in the questions. So you don't have to memorize this, but you need to write it down for your homework questions. So, we're going to look at different materials. So the first one is gold, which you have already, but you should maybe put it in a table. That's 19,320. Next, I think, is probably silver, which is 10,500. Nickel, 8,900. Now, I don't know if you knew this from chemistry, but salt water is a little bit more than normal water, 1,030. Fresh water, like in your bottle of water, that's 1,000. Tell me, ice. Do you think ice would be more or less than 1,000? Because ice is just frozen water. So what do you think? More or less than 1,000?
10.
No.
No?
No. Why less?
Because it floats.
Yeah, because it floats. Yeah. The ice must be less than water because it floats.
Well, why does it float?
Because it's less, the density is less than water, liquid water.
Oh, but the form changing from liquid to...
Changes its density.
Oh.
Yeah.
Which one should we use?
What do you mean?
Density or relative density?
It's enough to write down the density, because you can see the relative density is easy to figure out from the density. What's after ice now? So we're getting smaller. Alcohol, 789.
Do you have to memorize all these?
No, I said no. You should be given these in the exam if you need them. also important in chemistry and biology because of its properties. You can use it as a, what's it called, for like cleaning stuff, like a disinfectant, yeah. What else have I got now? Who the heck is this? Ugh. Right, next. Wood, 700, so that's why wood floats. Actually, it's interesting, not all wood is 700, it depends on the tree. But there is one tree, I can't remember what it's called, I'll have to look it up, but the wood is so dense it actually sinks. It's more than 1,000 kilograms per meter cube. I'll have to look it up, but most trees are less than 1,000. But there is one particular tree that's, I think it's in California. The wood is so dense that it would sink if you put it in water. Does anyone know this tree? No, have you heard of it? No. I think the reason it's so dense is because it needs to protect itself from the forest fire. I think. I'll have to check it out. Right, next, air. That is quite low, isn't it? 1.2. What I find amazing about the last one, the air, it's only 1.2. Just really think about that, okay? If you have a box, 1 meter cubed, how much air is in there? Only about a kilogram. Okay? If you take that kilogram out, then what you're left with is exactly what you would have in outer space. An empty vacuum. Okay? So the only difference between this room and the cold outer space is that there's 1 kilogram of air per meter cubed, which isn't really a lot. That's all that separates you from happily breathing and existing to not breathing and dead. Okay, so it just makes you appreciate the small difference between being alive and being dead. It's not a lot. It's not a lot. 1.2. Okay, you got all this written down? Yeah. Okay, so I think and hope you can do this one. The first one now, just before you start, what you have, 1 litre of fresh water, and you mix it with 1 litre of salt water. Now, I know it seems like litre is a normal unit, a metric unit. It's actually not, okay? The only reason we still use litres is because everybody still likes to use litres, but it's not a metric unit. It's not an SI unit like kilograms or kilometers or whatever, So whenever you're dealing with litres, you have to convert it into meters cubed or centimeters cubed or whatever. Now the first question is convert 1 litre into SI units. So you convert it into meters cubed. But how can you do that? Well, you need to know how big a litre is. So how many litres are in 1 meter cubed? Does anyone know? 1 meter cubed, how many litres is that? Anyone know? I'm sure somebody knows. I know. Because think about it, 1 meter cubed is pretty big, and 1 litre is pretty small. So how many litres in a meter cubed? 1,000. So 1,000 litres equals 1 meter cubed. I think from that you can easily work out how much 1 litre is. 1,000th of a meter cubed, yeah. Okay, right, I think you've got the idea. Try this one, won't take you too long to do. Tree, Kim, tree, it's tree, okay. Again, what's 2 called? No, just to make sure. Do you know 2? Squared, okay. 4? How are we doing? Which part are you on, Matt? B? Oh, come on, pick up speed. George?
C.
Siba, which part are you on? Oh, good, we're getting there.
Combine mass as in fresh water and salt water.
Yeah, mixed together, yeah. Say again?
Is the combined mass of fresh water?
The 2 mixed together, yeah. Kim, which part are you doing now? Maybe D, okay. If some people are asking me, combined mass just means total when you mix the 2 together. Come on guys, a little bit faster now. I want to see you sweating. Come on. You got it there, Matt? Finished?
I really want to apply it. Yeah. I really want to apply, but I can't. Yeah.
Okay, I better do it. Right, so the first one now. You said 1,000 litres equals 1 metre cubed, right? So for part A, 1 litre will be 1,000 of a metre cubed, which is 0.001 metres cubed. Happy? Okay. B. What is the mass of a litre of fresh water? Well, what's the density of fresh water? 1,000. And what's the formula for density? Mass over volume. So the mass will be 1,000 times the volume. which is 1000, times 0.001, which is 1 kilogram. Yeah, still with me? Right. What's the mass of the salt water? Well, what's the density of salt water? It's 1030. Okay? If density is mass over volume, then mass is density by volume, which in this case is 1030 by 0.001. So that's 1.03 kilograms. So far so good?
Yeah.
What's the combined mass? 2.03 kilograms, provided that you can add together, which I all know you can. Yeah? So, E, what is the combined volume? So the total volume would be 0.001 plus 0.001, so that's 0.002 meters cubed. And finally, F, what is the combined density? So that's the density of the mixture. So that's the mass, which is 1.03 of the 2.03 over 0.002. So that's 1.015 kilograms per meter cubed. I don't know if you're okay with that. Are you okay? Like, what confused you? You all look so confused doing this.
The 1 is equal to 0.001.
That confused you? Okay. But you're happy now? Seabeth? Yeah? Kim? Is okay? Are you sure? Alright. I can continue? I can continue, yes? Okay. Right, this is a question that we do together, just it's a story, okay? So, actually, maybe if you hand me one of your empty bottles there as a demonstration. So, this, imagine, is filled with water right to the top, and there's also some ice in it, but there's no space at the top. Like, the water goes right up to the top, and the ice is underneath. There's no space extra. The student closes it tightly. There's no extra space, and then this is put. This water is left out, just on the table there, and the ice inside starts to melt. The ice that's inside here starts to melt. Okay, got the story so far? When the ice has fully melted, what has happened to the bottle of water? So let's consider the three possibilities here. Firstly, the volume of the water in the bottle has increased. Since the bottle is closed, the bottle now breaks because the water volume increases, but there was no extra space, so the top breaks off the bottle. Or B, the volume in the water has remained unchanged. So there's just nothing happens, it's all the same. And then C, the volume of the water has decreased, and now there's a little bit of space at the top of the bottle. So think about the story, and then tell me which you feel is right here, A, B, or C. You're going with B? Okay, good. Let's see. I never had the whole class agreeing, so I'm sure there's other people who would disagree. So we have two people who think B. What do you think, Siva? Or Kim, which do you think? You're going to go with those two. You trust those two. Okay, B as well. I have another B. Kim? You're you're saying just not B. It has to be A or C. Okay, fine. And any ideas?
A.
Oh, you've changed now to A. Okay, good. All right. And
I'm going to go with majority.
Okay, all right. That's B then, is it?
Yeah.
Okay, so we have B, 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 A, and not B. Okay, Chow, any ideas?
Nothing.
You're just saying not B. Okay, but you're not sure if it's A or C, is it? Well, I'll tell you the answer. You're all wrong. kind of, because it's actually C.
Already?
Yeah. Yeah.
What?
Yeah, it's strange, but think about this, okay? The ice has a lower density than water, right? So when it turns back into water, it's now more dense. So does that mean it needs more space or less space if it becomes more dense? Less space. So the bottle, it actually shrinks the water inside. Yeah, it's interesting, isn't it? It's interesting. You know, this is only because the lid is actually closed. If you're wondering if the lid was open and the ice was half in the water and half out, you know, floating on the top, then the answer would be B. No change. Okay? But it's definitely not A. Right? Now, this is actually important because it's a basic science fact that I think people forget about when we talk about climate change. Because you probably all heard in climate change, when the ice melts, what happens to the water? It rises, but it doesn't actually, not according to this. Now, that's not to say the water won't rise. It does rise, but for a different reason. It's not because the ice is melting. I think what happens is, I can't remember exactly, but when the ice melts, some snow that was on the ground, maybe it melts into the ocean and becomes water. Okay, so the ocean will still rise, but it's not because the ice is melting. Because if the ice was melting, in fact, there's no change. Okay, so it's one of those things that people are surprised about, but when you explain it, you're like, oh no, it makes sense when you think about it. Okay, good. So this last one here. This one, so the previous example is not in the exam. It's just for us to think about. This is the first question that we're doing, which is like an exam question. So this would be a section A question for like 4 marks, something like this. Silver jewellery. Does anyone have silver on? What the heck is that? Okay, that's not silver then. Anyone have silver? No silver? Only gold? So actually some cheap silver jewellery is actually not pure silver, it's a mixture of silver and nickel. I don't know if you've known this, yeah. So what they do is they take some nickel, but then they cover it in silver. So for example, if you had something which was 10 grams of nickel and 1 gram of silver, that would be like a little piece of jewellery. I want to know what is the density of this mixture. This is a lot like my first example here, okay? It's a little bit harder because I don't give you the steps, but you can think about the steps that you did here to get the answer here. You have the density for silver, what is it? It's 10,500, yeah? And what's nickel? Okay, so before we calculate, sadly it's not that simple. Yeah, before we calculate, I want you to tell me what you think your final answer will be close to. You have 10 grams of nickel and 1 gram of silver. So your final density, will it be closer to the nickel number or the silver number? What do you think? Yeah, give me your reason why. Yeah, that's it. You have more nickel. So whatever answer you get, it should be near the nickel. What's the number for nickel? 8,900. So for me, if I got an answer like 9,000 kilograms per meter cubed, I would think I'm probably right. Because it's close to nickel, but it's a little bit more because you mix in the silver. Yeah. Right, try to calculate it and then I'll do it for you. Good question. I don't actually specify, do I? So you could either give me the answer as kilograms per meter cubed or grams per centimeter cubed if you prefer. But I would personally prefer kilograms per meter cubed if you can. How are we doing, children? Any answer?
9,052.
Seems believable, doesn't it? Anybody else got an answer? George? Kim, any answer? Do you think you'll get one soon? I mean, do you have an idea on how to do it? Yeah. Siva?
Incorrect.
What you get?
1,000.
Yeah, it's not.
Yeah.
Okay. Let's have a look at the answer now. So, I understand this question can be a bit confusing, but if you just think about precisely what you want, it's a little bit easier. So, precisely we want the density of the mixture. Yeah? The mixture of gold and nickel. Okay? So that means we need to work out the mass of the mixture divided by the volume of the mixture. Now the mass we could work out because it's the mass of the silver plus the mass of the nickel. And these are two things we know. Over, and what's the volume of the mixture? Well, it'd be the volume of the silver plus the volume of the nickel. Right, do we know the mass of the silver and the nickel? How much is that? What's it, 10 grams and 1 gram, isn't it? So it's 11 grams. So it's 0.011. But now we have a little bit of a problem. What's the problem now? Do we know the volume of the nickel? No. Do we know the volume of the silver? No. But if we use this formula, what could we change volume into? Volume can be equal to mass over density, right? Yeah? So you could change this into 0.11, the mass of the silver over the density of the silver, plus the mass of the nickel over the density of the nickel. What is the mass of... Oh, sorry, I lost a zero there. What's the mass of the silver?
0.0.
Is it 10? No, it's 1, isn't it? 0.001 gram. And the density of the nickel? The silver? 10.0500. And then, what is the mass of the other one? It's 10 grams, isn't it? And the density of the nickel? 8,900. Yeah. Could you just hit that in? Make sure we got the same answer, Matt.
9,025.
What did you get, Siva?
9,025.
Ooh, that's a little bit different to your answer, isn't it?
9,045.
Oh, hang on. I got 9,025, 45 and 52. What is it exactly? You've typed it exactly in?
Oh, because I rounded up.
Oh, you rounded earlier. Okay. Well, this would be the exact answer because I didn't round anything yet. So what did you get, Siva?
9,025.
For this expression?
0.02.
Yeah.
I got this.
What did you get? 90?
9052.
Yeah. They would. Last year, when students had that level of difference, they still gave them the mark in the exam. So it's okay. Because the reason for the difference is only because of rounding, yeah? So. Right, is that okay? Do you remember at the start I kind of said, oh, an answer near 9,000 would be good. Seems good. This is a section A question on density. Now that you've seen it done, I hope you don't think it's too difficult. Now that you've seen it. Yeah? Okay. That's the final example. So, I'll let you try the questions for a few minutes before we go on to the next lesson. What's that movie?
It's Charlie.
Is it? Okay.